In July of 2026, astronomers announced something no rocky planet outside our solar system had ever shown before. An atmosphere detected, confirmed, in a habitable zone. The headlines wrote themselves. First atmosphere found on a habitable rocky world. A major step in the search for life. Scientists celebrated. Reporters called it a turning point. But read the actual paper, not the headline, and the story changes completely. What they detected wasn't a planet holding onto its air. It was a planet losing it, in real time, caught in the act. The gas wasn't sitting calmly around the planet. It was streaming away from it, into space, escaping the planet's gravity at that exact moment we happened to be watching. And when astronomers looked again a year later, expecting to confirm what they'd found, the signal was gone. Not weaker, gone. Nobody knows why. What we're about to walk through isn't a story about finding signs of life. It's about how a planet bleeding into space got mistaken for one. LHS 1140b orbits a small, dim red dwarf star about 48 light-years from Earth. On paper, it shouldn't be special. Thousands of exoplanets have been cataloged since the 1990s. Most are gas giants, bloated worlds with no solid ground, nothing you could ever stand on. LHS 1140b is different. It's rocky. It sits inside its star's habitable zone, the narrow band of distance where temperatures could, in theory, allow liquid water to exist. That alone made it interesting years ago. What makes it interesting now is its star. Red dwarfs are usually violent neighbors. They flare constantly, blasting nearby planets with radiation. LHS 1140 is unusually quiet, calm by red dwarf standards. For years, that calm made this system one of the best real candidates in the search for a habitable world close to home. Then, in observations from 2024, something happened. As the planet passed in front of its star, astronomers caught a signature in the light: helium escaping from the planet's upper atmosphere. For the first time, scientists had direct evidence that a rocky planet in a habitable zone around another star actually had an atmosphere at all. It was framed as confirmation, as proof this planet had what it takes. But nobody stopped to ask the more uncomfortable question, hidden inside that data. You don't detect gas escape in a planet by watching it sit there peacefully. You detect it by watching it leave. And once you sit with that distinction, the story stops sounding like good news. Here's what astronomers actually measured. As LHS 1140b crossed in front of its star, some of the star's light passed through the very edge of the planet's atmosphere before reaching our telescopes. Buried in that light was the fingerprint of helium, a gas so light that gravity struggles to hold on to it once it reaches the outer edges of an atmosphere. That helium wasn't just present. It was moving outward, away from the planet, fast enough and in large enough quantities to be detectable across 48 light-years. In plain terms, the planet's atmosphere was venting into space while astronomers watched. This process has a name: atmospheric escape. It's the same mechanism that stripped Mars of its air billions of years ago, turning a once wet world into the frozen, barely breathable rock it is today. When a planet loses atmosphere faster than it can replace it, the ending is always the same: thinner air, weaker greenhouse effect. Eventually, a surface exposed directly to the vacuum of space. So why did this get reported as a win for habitability? Because for the first time, it proved this class of planet can hold gas at all, even briefly. That's a real scientific milestone. But it says nothing about whether the planet is keeping that atmosphere or losing a race against its own star that it's already destined to lose. The paper didn't claim the planet was thriving. It claimed the planet was leaking. Somewhere between the observatory and the headline, leaking became confirmed atmosphere, and the warning buried inside the discovery quietly disappeared. And then, the story got stranger. If the escaping helium had been a one-time event, astronomers could have explained it away. A stellar flare, a brief disturbance, a coincidence. So they went back. In 2025, they observed LHS 1140b crossing its star again, expecting to see the same signature confirmed a second time. They didn't find it. The helium that had been unmistakably present in 2024 wasn't there in 2025. Not fainter, not partially visible, absent. The team didn't dismiss the first detection. They went back through the data, checked for contamination from Earth's own atmosphere, ruled out instrument errors, tested other explanations. The 2024 signal held up. It was real. Which meant the only conclusion left was harder to accept. The rate at which this planet is losing its atmosphere isn't constant. It changes. Sometimes there's an observable leak. Sometimes there isn't. And right now, nobody can explain what's driving that variation. It could be activity on the star itself, a flare, a shift in stellar wind, something reaching out and stripping gas from the planet in bursts. It could be something happening on the planet's side entirely, tied to its own magnetic field or its rotation. Because here's what else we know about LHS 1140b. It's almost certainly tidally locked. One face permanently turned toward its star, one face in permanent darkness, with a narrow twilight band caught eternally between fire and ice. And the mechanism that normally helps a planet regulate its own climate over millions of years. The slow chemical cycling between rock and atmosphere. That keeps Earth's air stable. Likely doesn't work the same way here. Without exposed land, without that stabilizing feedback loop, an atmosphere on a world like this has fewer ways to protect itself once something starts stripping it away. We caught this planet's atmosphere doing something unpredictable. And we still don't know if what we saw was a permanent leak, a temporary storm, or the early signature of a slow disappearance we're only just beginning to notice. Zoom out, and this stops being a story about one planet. Roughly 3 out of every 4 stars in our galaxy are red dwarfs, just like LHS 1140. And because red dwarfs are dim, their habitable zones sit close enough that most rocky, potentially Earth-like planets we've found orbit tightly against stars just like this one. Every major upcoming mission built to search for life leans on exactly this kind of system, because these are the planets we can actually observe in enough detail to check. Which means LHS 1140b isn't an edge case. It's close to the best-case scenario. A quiet star, a rocky, water-rich world. The first confirmed atmosphere ever detected on a planet like this. And even here, in the most promising system we have, what we caught wasn't stability. It was a planet's atmosphere behaving unpredictably, disappearing and reappearing in ways nobody can yet explain. If the calmest star we know still can't guarantee a planet keeps its air, the question stops being, how many habitable planets are out there? It becomes, how many of them ever get the chance to stay habitable long enough for anything to happen on them at all? JWST and future telescopes will keep watching this planet. Maybe the next observation confirms the leak was temporary, a passing event in an otherwise stable world. Maybe it confirms the opposite, a slow bleed that's been running for millions of years, one this planet was never going to survive. Right now, nobody knows which version of that story is true. The headline already told you the comforting one. We just showed you the version sitting underneath it. If you want to keep seeing what's actually hiding behind the space headlines everyone else is celebrating, this is exactly what this channel does. Subscribe to Star Voyager, and we'll keep going past the press release every single time.